Good afternoon, everyone. Today, we are going to witness a paradigm shift towards product development by leveraging the 3D experience SolidWorks. I am Solanki Diviraj, working as an application engineer at Engineering Technique. We are authorized reseller of the SolidWorks and 3D experience based at Gujarat, India. And having the offices at Vadodara, Ahmedabad, Surat, we are having a team of certified experts and professionals who can provide enhanced customer experience. Next. So, being a reseller, we are not only selling the tools, that's what the misconception people are having. Okay. So we are not only selling the tools, but we are providing intuitive solution for every stage of product development. Okay. Whether you want to design your product, create a CAD model, then whether you want to, simulate your product to validate, and then if you want to sustain that data for your product, and whether you want to communicate with internal stakeholders as well as external stakeholders. So we provide, intuitive solution for each and every department that exists in a product lifecycle. And after the pandemic situation, majority of us have to adapt the new normal of working from home. All right. And I'm sure many businesses have adapted this in the routine. And without the right tools, this environment can present some real challenges, whenever you are, try to continue designing and developing your products in SolidWorks, there is a loss of efficiency also includes. And if you want to share and collaborate your data with, your own colleague, or whether you want to, collaborate with external stakeholders, it is going to be very tough. So we are going to present your solution regarding all of the issues, and we call it a 3D experience SolidWorks. So as an example, all right, to demonstrate our solution, we are going to develop a filling and labeling machine. Okay. And throughout that process, we are going to see, what is 3D experience platform. We are going to see an overview of it. Then we'll see, what is a lean team meeting, how we can arrange a team meeting through our, lean tools. Then we'll see how we can execute our project planning with the help of 3D experience tools. How easily we can do it, how interactively we can do it. And then we'll witness what is Incontext Modeling in our SolidWorks CAD tool. Okay. Then we'll see what is the issue management. Whenever you are creating a model, whenever you are, developing a product, there will be some issues. So we'll see how we are going to manage them. All right. Then we'll see what is structural system, how we can validate our design within a few clicks. Okay. And at the end, we'll witness, what is SolidWorks Motion. Okay. All right. So this is our CAD model of a filling machine. You can also use your CAD data into PPT, just like I've used it. Okay. It is an interactive 3D model. So to demonstrate such a solution, we'll take an example of the small design team to see what it looks like to store and manage the collaborated data into the cloud. Right. So let me introduce you to my team. Diviraj is a design manager. Anirudh and Kiran are the engineer, and the Jaimin is my production guy. All right. Okay. So Diviraj is going to introduce you, 3D experience overview. So 3D experience SolidWorks is a cloud-based system, and licensing and login is basically email-based. So now Diviraj is going to show you, interface by logging into the browser. Okay. So let me first start by logging into the browser. Okay, so we logged in. First, what we have seen here is a dashboard. All right. So dashboard is a fully customizable interface in 3D experience platform. We can customize it as per our need, very easily. It can be customized as per the roles like, manager and engineer. So I've created, two dashboards here, filling labeling engineer and filling labeling manager. I'm switching in between them, okay. And then tabs. So tabs are used to manage our tools and data. Okay. So we have tab of key figures tab, where I'm attaching my Excel data files like order state, delivery curves, order per annums. I can also change, types of bar. So these are the all, my, I can say, boring data got converted into the infographics. I can also change the, bars, whether I want vertical bar, horizontal bar, pie chart. Yeah, I can do it. And in analytics and learning tab, I'll have a frequently visited website loaded in web page reader. If I want to get updated with the market trends and associations, I can do it. I also set up a news feed to get updated for the market in a feed reader, right? And then lastly, I have a 3D learn where I can learn about new rules and app regarding the 3D experience. Okay, so tabs contain meaningful app and widgets. So I'll switch to the data drive, and in the data drive, they can store the data in folder structure, same as a local drive folders, but on secured cloud storage facility. So I'm loading, my 3D files to preview in 3D Play. We'll see what is 3D Play. So let me first load some of the files from my local to 3D drive. So just within a few drag and drops, my file has been uploaded there. I can see the preview, okay, easily. And we can also create folders easily. So I'm creating a new folder named machine parts. I'm creating a random folder, and I'm just dragging dropping my old parts into that folder to manage it. So you can see how easily you can do it. It is just like the file explorer we are using every day. Okay. Okay. So, let us more talk about 3D Play. So I'm loading a assembly. So there is a lot more capabilities in 3D Play than just to preview the files. How? So let us see. So in the tools tab, you can see that we have option of, change the display style of the 3D models. So we have many options, like if you want shaded, edged, wireframe, we have lots of options. Right? You can also auto explode your assembly to get better details of the internal parts, right? It will explode each and every part subcomponent of your assembly. Okay. Then we have option of, creating the section. We also have, preview. If you want to create a preview of a section model, you can easily do it. You can change the, cutting plane. You can change the position, change the angle of your cutting plane. Okay. So handling is way better. All right. And we also have, measure tool. So if you want to measure the distance between two faces of the part, you have to just select the starting and ending face or starting and ending point, and you will get the distance in between them, right? So, we can say that it is similar to the e-drawing, but it is a web-based app. Now we'll switch to the project spaces. And in the collaborative space, we can create a space for our project and also configure the member that are involved in it. Okay, so only involved member will have different level of access. All right, so I have created my gearbox and machine mold. Okay, let me introduce you to the lifecycle tool. And with the help of lifecycle tool, we can manage the different approval process of the product. So I am basically, I have loaded a file. So what I can do here, I can change the maturity state of the design from in work to frozen. All right, or directly release. So what I'll do, I'll just change that state from in work to frozen, and then what I'll do, I'll release that product. All right. So the whole life cycle is managed throughout these tools, and we have some also tools like new branch, new revisions. We can easily do it. And let us switch to the community. So community is like a social media for the corporate world or the enterprise. It stores the history of conversations, helps you to collaborate better on the project. Yeah. Okay. So we have initiated a filling and labeling machine project, and my engineer have updated me through the community. So he has updated me. Kiran Khatri is my engineer. So he has updated me like, yes, I uploaded the assembly with all the reference files on the 3D drive. All right. So he has uploaded all the reference file in the 3D drive. So what I'll do, I'll just give him a quick reply through the comment. I'll write him, okay, I'll review this assembly as soon as possible. Right. So it is just like using the Facebook, but for the corporate world. So I'll just send him this comment, and he'll get notified through the notification center. All right. Okay. So let me go to my 3D drive where my engineer has uploaded that file, and let me review that assembly using the 3D Play. So you can see how quickly my file has been loaded into the 3D play. It is a way bigger assembly, right? So my assembly has been loaded into the 3D play. And I have some suggested changes that I want my team to know. So in 3D play, with the markup tools, I can highlight the changes. So I'm currently highlighting that particular areas of my assembly that I want to add notes or give annotation. And I'll attach a text note to this particular arrows. So my first one is to add a joining plate to the machine. I want to join these two machines. So I want to, I want my team to add a joining plate to the machine. The second is to add the bracket. There is no bracket into my filling machine here, over here. So what I want my guys to do to add the bracket here. Okay. So I made the suggested changes, and what I'll do, I'll just click on publish to 3D Studio. So I can directly publish this screenshot to the community. Okay, first of all, I have to select the community, which is filling and labeling machine, my current community. I'll add the title according to my convenience. Okay. Like add the suggested changes, and I'll also add the comment, do the needful and all. All right. And I have published it. Okay, so content has been fully published. We can check it into the community that it got posted. Yes, it got posted. All right. So post has been made into a community. So what I'll do now, I'll create a collaborative space regarding the project because I want to, initiate my project way further. All right. So what I'll do, I'll create a collaborative space to, handle the whole life cycle of my project. I'll add the title of filling and labeling machine and just create it. Right. So what I'll do, I'll launch my SolidWorks from the 3D Experience platform. Okay. All right. I already opened one session of my SolidWorks, so I'll just go there and open it. Okay. Yeah. So I'll load the file from the 3D drive. I loaded the file from the 3D drive. Then with the help of 3D Experience add-in in SolidWorks, it is the add-in. I can, save the files to my preferred spaces. So edit in the edit preference, you can, set the credential to your own collaborative spaces. And with the help of option like, save with options, we'll save this particular file into our desired space. Okay, so I am just clicking on save to save this particular file in my space. All right. Okay, so it got saved up. You can check it to the space that all the file is uploaded. So I'm going into the space and checking that my space has been filled with my all the project file and the sub assemblies of that files. All right. Yeah. So next we'll see bookmark editor. So with the help of bookmark editor, we can bookmark the necessary files into a structured manner. All right, I already created a bookmark for filling and labeling machine where I uploaded my bottle packing machine, only bottle packing machine. All right, so I'll create a new bookmark to add my filling machine also. So I'll label that bookmark filling machine. All right, and I'll upload assembly from here. I'll search my assembly name. Right. Okay, so what is my assembly name? Yeah, Mac-1600. So I'll search for that, and with the help of 6W tag, I can easily search anything. All right. So I uploaded my assembly after searching, and you can see whole product structure has been uploaded easily, and we can also see the preview in the 3D Play. All right. So 3D Play is a really great tool whenever you want to, check out any kind of CAD file, any kind of file. I'm not just saying CAD file. You can easily check it. All right. So my assembly has been uploaded completely. So now, what is our next step? Our next step is to have meeting regarding the project. I have initiated a project called filling and labeling machine. Yeah. So let us initiate the meeting regarding the project. Okay. So let me go to the meeting and planning tab, and I already created the meeting into my lean board, which is named a filling and labeling machine, and I have added appropriate link gates. All right, link gates are different tool widgets that can add to a lean board. This is my lean board, and board contain every needful tool to initiate the meeting. We can add members to the meeting. Okay, so I'm currently clicking on the plus sign, adding Kiran, my engineer, over to my meeting. All right, so pretty simple. Just search for the guy and add to the team. All right. Okay. So through the customize option, we can edit the team boards by adding the link gates as per need. So I'm searching for 3D play to premium assembly. Okay. So I placed that 3D play into my link board. I also added problems and action log link gates as per our need. So let us my assembly over here to preview it. So and yeah, I got my assembly over here. I'll drag and drop and it got loaded. Pretty easy and fast. All right. So let me switch into the sketch tab where the meeting is going on about what are the crises in our filling and labeling machine that we are facing currently. So we can give our thoughts and opinion through e-notes. Okay, so let us see how we can add the e-notes. So we'll go to that edit tab. All right. We can bifurcate our e-notes into action and problem. We have a teams where we can assign, and we also have option of stamps, facility of the stamp stickers, whatever you say. Okay. So what I'll do, I'm stating an issue of vibration that are facing into the machine. Okay. So what I'll do, I'll just write labeling machine vibration control. That is an issue. I was related it as an issue. All right. Okay. So we can bifurcate problem and solution by the color. I'm currently providing a solution in different color, which is a yellow, light yellow. All right. So I've created a solution for controlling the vibration, which is a create clamp plate for connecting the machine. Right. So first of all, I want to streamline the packaging machine. So I'll create a one knot. Then second knot is we need to upgrade the clamping bracket to control the vibration. Again, I've created it as an action log. Right. Okay. So now what we do, we'll assign members to the desired action by dragging and dropping action and problems both. So I'm just dragging and dropping members from the team, and I'm assigning members to the action and problem block. All right, so that way they can know, this will be handled by me or that guy, right? Okay, so we can directly link that actions to the problem. I open the problem and linking the action to that particular problems, right? So, okay, so I'm linking the action. We can create new actions. I'm creating some new actions. All right, create a new concept for the structural systems. Okay, and I'm assigning multiple action to the problem block pretty easily. You have to just open your problem block and assign it. Right. And I'm also analyzing the assembly motion. I'm creating as much as action that I need, and also assigning the stamps as per the urgencies, whether it is high, low, medium. Okay. So pretty easily, I'll just drag and drop my stamps to assign it to the nodes. Right. So what I'll do next, I'll go to my problem link gate. Okay. And where I can bifurcate problems on the priority basis, like urgent, whether it is urgent, high, medium, or a low. Right. And through customize, we can also change this interface, but I don't want to do it right now. Same in a action log. In action, we can also prioritize this node from urgent to high to medium and low. Pretty easily we can bifurcate, so that way we can know what what kind of urgency we'll having, and we can access these tools, stickers from anywhere we want in every link gate pretty easily. Right. So let us jump back into the meeting where one of my designer have a query like how we can create a plate for joining two machines. Right. He's asking me a question. So it is a problem regarding, design. So let me go to 3D play. 3D play can help us to capture the screenshot of the design portion that I want to mark up for the, design explanation. And so I'll just save the screenshot from the 3D play. And what I'll do, I'll just insert it into the sketch by dragging and dropping pretty easily, right? So I'll just drag and drop that screenshot from the 3D play that I have taken. I'll just adjust the size. Okay. And I'll make him understand the concept and the design intent of the plate. So I want him to use already existed holes to create the plate. So basically I want him to do, in context modeling in this particular plate. All right. So I just given him a rough sketch, how he'll going to use the holes, what will be the shape of the plate and all. All right. So I've suggested him changes. Now what I'll do, I'll go and create a note, action note to this problem. All right. So like create a plate through Incontext Modeling, and I'll just simply drag and drop that onto the problem. So it will got linked automatically. Right. Okay. So pretty easily you can handle these tools. You can communicate way better. And after creating all the action log, what we'll do from the action log itself, we can assign the action as per task to the assignees. All right. So we'll directly create a task according to these actions, and I can directly send it very easily. All right. Let me assign some more members to the task and create task for them. So this task will reflect into the collaborative task tab. Okay. So I'll go to my user task tab, and there is collaborative task app where you can see all the tasks that has been reflected. All right. Okay. And we also have options, to change the properties of the task, like whether we want to attach any file regarding that task. So I'm attaching my, bottle packaging machine over here, Okay, then we have option to, arrange the priorities according to our need. Then, how much percentage this task has been completed. What is the plan start of that date? What is the end date to complete this task? What is the estimation duration? What are the deliverables? So there are so much properties into the, task, collaborative task. And we can also, our task will, go into to do to in work, and after the in work, it will go to the completed. So it will complete its own 3 phases. All right. Okay. So let us move next to, project planning. So we have completed our meeting. All right. And so with the help of our tools like project planning tools, what we'll do, we can define the milestone, make the task, can create the interdependencies in between the tasks. All right. So let us plan our project. Okay. So we'll create a new project by adding a picture and title to it. All right. So I'll add the title of filling and labeling machine. I already added the picture above. All right. And what I'll do, I'll create a task. Okay. So here we have different tabs available. All right. Schedule, dependencies, members. Okay. So first we'll go to schedule and create a milestone. Milestone will be like, I want to streamline my whole filling and labeling machine. Okay. So I'll name that milestone. I'll add the suggested date to end this particular milestone of my project. All right. And then to achieve this milestone, I'll create a task. All right. These tasks are the same tasks that we discussed into the team meeting. Okay. So my first task is to, create a clamp rate. So why do I need the clamp rate? To, attach two machines. Right. Then I can add the assignees over here, but I haven't added any assignees to this milestone. So what I'll do it later. I'll just add here a plan start and end date. Right. You can also set the duration and, tolerances if you want to give some. So I've created my first task. Again, with the same technique, I'll create the second task, which is clamp bracket for, filling machine. All right. I can also add some description to it. Okay. upgrade, sheet metal part to the machine part. That will be my description. Okay. Then the sheet metal to the machine part. Okay. And then I can plan my start date for this particular task and also the end date. All right. So from that way, I've created my 5-6 tasks that we have discussed into our team meeting. All right. And now what I'll do, I'll add the members to our project planning. So we have a different level of access like leader, author, and viewer. So we can add, members according to it. Then we can decide, who will do what kind of task, right? So I've added the members. I'll go to the schedule. I'll go to the task. All right. We have added the members. The pop-up has been raised. All right. So what I'll do now, I'll go to the task. Okay. First of all, I'll go to the member and assign the members to the task. I can just click on the assign is tab and just search for the members that are added into it. And I can assign it pretty easily. I can also assign some of the tasks to myself. We have direct option for that. So I'll assign some of the tasks to myself also. Okay. And we can also add and remove any members. So pretty easily. All right. And by dragging and dropping that plus sign, we can create the interdependencies of the task. Okay. So my filling and labeling, so my filling plate depends on the joining plate, and the review task is depend upon both of its previous task. All right. So now my channel has been created, and now structural system concept of new structural system is also depend on the creation of the clamp plate, and the validity is depend upon the structural system new concept. And then at the last, we'll create a motion study, right? So the interdependencies has been created throughout the whole task. So I'll know, what task we have to do first and what last. And in the task tab, we can see all the tasks that we have created. All right. And in the summary, we'll have an infographic information about the task, what are the risk assessment, what are the tasks and all. Right. So now what I'll do, I'll check all the properties of the task. So yeah, dependencies has been created, schedule has been done. All right. Now what I'll do, I'll attach some deliverables. So we have already seen these properties of our task. I'll attach some of the files that will be required to complete the task. All right. So let me go one by one to the task and attach the files. We can also change the description. So I am changing the description for one task, attaching my machine or whatever assembly it is. Okay. And now all the things looks great. All right. So yeah, my project planning is, I think, completed. I've seen all the aspects. So let us jump into the execution. So my user Anirudh will finish his task first. All right. Okay. So he's modeling into the 3DEXPERIENCE SolidWorks. And with the help of 3DEXPERIENCE add-in, he'll go to his task, to the collaborative task, and load the assembly from there. All right. So first let him add, a collaborative task and go to his task. And he'll just drag and drop assembly from the attachment into my SolidWorks environment pretty easily. All right. Okay. Then he'll move the task from to do to in work, because he is, started to work on to this particular task. So everyone will get to know, yeah, this task is in work stage. All right. So he'll add a new part to create that plate. He'll log the assembly first. All right. So he has entered into, editing mode, CAD editing mode. And with the help of sketch tool, he'll capture some of the, already existed profile. So what he is doing here, he's using the already existed geometries to capture the profile. He doesn't want to create it from the sketch. It is called Incontext Modeling, where you use already existed profile to create your own model. So that way it will be reference to that particular, reference to geometry from what it have inherited that particular shape. All right. And after the creation of profile, he is using, some sheet metal feature to create a base flange. So you can see how easily and how quickly he can preview this assembly while, designing this. And, it become dynamic with the reference to its adjacent geometries. Right. So whether the adjacent geometries changes, the shape of this whole plate will be got changed. Okay. So he's capturing here, and you can see the preview of the real-time clearance between the plate and the that filling machine rack. All right. Now he's capturing some profile to create the holes. Okay. He'll again taking the reference from another profile that has been located way behind. So he is just taking the reference, geometrical reference, and he is creating some profiles to make the cuts, to make the material removal from this plate. Okay. He is constraining this sketch profiles with the help of dimensioning options. Okay. So constraining got way easier. Minimum dimensions are there. We have reference geometries. So whenever reference geometry got updated, your original design will get updated real easily. Okay. So he'll initiate some extrude options, basically material removal feature. All right. And his plate has been created. He'll mirror this plate exactly to the second side because it is the requirement. All right. With the help of mirror component option, we can easily mirror those profile to the other side. All right. Okay. So I'll choose the dynamic option and just click on the save. Okay. The saving process of the part has been automatically started. All right. Okay. We'll cancel this. Okay. So my part has been mirrored. What I'll do now, what he'll do now, he'll change the name of the part. All right. And he'll save it. Okay. It's previewing the assembly like everything looks fine. Okay, so now what he'll do, he'll open the, this particular part. He has opened the part. Okay, he'll save this part, first of all, to this PC. All right. Okay, so saving has been taking place. And now what he'll do, he'll create and, manufacturing drawing of that particular part. So first he'll select the sheet, which sheet he wants to create. And then he'll project some of the views that are required. Okay. He has also, created a flat pattern development. All right. Added some dimension with the help of, model import, which can import the model dimension. He'll save this drawing into the folder, local folder. All right. Now what he'll do, he'll go to his current session and save all of these, parts and this, manufacturing drawing to the collaborative space. All right. So he's just saving it into a collaborative space pretty easily. So the revision has been added, the file has been saved. All right. So let us move into our measure assembly. Okay. So my measure assembly has been updated. So the new revision will be the revision B1. Okay. So while saving the assembly, we'll add a new revision to this particular assembly. Okay. So we have options. We'll go into the revision column. Okay, and just click a tick mark for the new revision for bottle packaging machine. That way my bottle packaging machine will got updated, and I'll also add a revision comment for the history purpose. Okay, so my second revision will be like I've added the connecting clamp plate. All right, and just save it. And you can see in the preview of my session that revision B1 has been updated. All right, and user task has been completed. So he'll go into the user task, and from in work, he'll change the state from in work to the completed. All right, so he'll just drag and drop that task and he'll go into the task properties because he has created that clamp plate. So what he'll do, he'll just attach that clamp plate into the deliverables. So that way his manager will know, what are the files that have been changed or the new created files. All right. So he'll attach that particular file into deliverables for the review purpose. And then, yeah, he attached the file and save. Okay, so now his task has been successfully completed and he has updated into his collaborative task also. All right. Okay, so the same, whatever the changes he made, he'll also update it into the community. So he has loaded the file, that revision B1 file into 3D Play, and you can see that the clamp pad has been added. All right. So now what he'll do, he'll go into, that what I've witnessed earlier, capabilities of 3D Play. He'll use some of the markup tools to highlight the changes that he has made. In the same technique, he's adding a comment to the changes. All right. And he'll upload the screenshot from this 3D Play into our community. He'll select the community, add the title. We already witnessed this thing. Okay. And just publish it. All right. So he has published the changes into the community. That way, the whole people that are involved in the project will get to know that the changes has been made or the task has been completed. All right. Okay. So as you have seen, the process of planning and execution of the task is very easy and very traceable. Okay. So now next, let us focus on how do our team manage the issue that comes under a project development. All right. So we'll see, issue management. So my engineer has informed me through the community that we are facing some issue into the filling machine. The issues are regarding the vibration. All right. So let me go to my revision management tab. I already read the comment. So let me go to the revision management tab and I'll, review this whole assembly through the issue review 3D tool. Okay. So my assembly is getting loaded into this issue review 3D tool. And with the feedback of my production guy, I have spotted the part that was causing the vibration. So I will create an issue, right? Okay. So I'll click on that plus button and create an issue. Okay. I'll give a title to it. Change the filling plate. Right. I already added credential to my space. I'll set the priority, set the due dates. All right. Okay, and I'll go to the content where I'll attach the problematic part by using the interactive 3D selection. So what I'll do, I'll go into that interactive 3D selection. Okay, and I'll select the part that is causing the issue. All right, so I selected the part. As you can see in the pick 3D option, I've selected a part. And we also get option to select the component according to the assembly hierarchy. Okay, so that part will affect my subassembly. Okay, so I also have to choose a subassembly, and that subassembly will create, issue in my main assembly. All right. So this is whole product hierarchy that we have to attach. And after into the attachment, we have options to, mark up whatever the changes we are suggesting. Okay. So pretty easy tools to use. All right. We have some, markup geometries that we can add. We have options of add the nodes to the markups, change the color of the nodes. So I'm just adding a node over here, change this plate, change this bracket. All right. I can change the color, stroke, shades. So all are the useful handy options. And then into the members tab, I'll add the assignees who are going to handle these issues. All right. So by myself, I am handling the issue. And I'll also adding Anirudh, my design engineer, to it to look into it. And I'll just click on the start. All right. So my issue has been created successfully. You can see that what are the attachment and all. Okay. Okay. So what I'll do, I'll see where my newly generated issue has been reflected. So it is basically reflected into my issue management app. All right. So you can see in my issue management app, my newly created issue of changing and filling machine plate has been reflected. And by clicking on a plus button, you can see the whole hierarchy. You know, what are the parts that I have attached. In the content tab, you can see what are the part I have attached. All right. You can change the properties. In attachment, you can see if any markups that I have added. Okay. And we have some other options we'll explore later. Okay. And into the members tab, you can see, I have assigned Anirudh and all. So I can also add the comment over here. I'll tag the Anirudh. All right. Okay. And add, comment like make suggested changes. All right. And to initiate this issue, I'll create a change action. All right. So I want, to get started working on the issue. So what I'll do from by my side, I'll create a change action. I've added the title already and I'll add the description. So description will be from sheet metal to machine part. Now I want this part to be changed as soon as possible. All right. I'll add the severity and due date and save this as a draft. Okay. So what I'll do. Okay. I'll go into the change execution tab and I'll add assignees and I'll redefine myself. So let me be the approver of this change action. I'll go into the proposed changes. All right. And what I'll do, I'll do change assessment. So in the change assessment, we have an option of the relation explorer where we can explore, the part that was causing the issue and its relation to the files. Okay. So part has been attached to, many hierarchies. So currently it's been, attached to my filling machine and my filling machine is to connect it to the, labeling machine. So whole hierarchy you can attach and then I'll check everything. I'll send it into the work. So my change action has been, send it into the work. Okay. So my engineer will got notified through the notification center. Okay. So now he'll do his part. All right. So what Anirudh will do, he'll start working on that change action quickly. Okay. He'll go into again his 3D experience edit tab where he'll load, change execution web app where he'll find, change action that I have currently created. All right. Okay. So change the filling machine, change action, and he'll simply drag and drop the file that are necessary. So he has dragged and dropped the B1 revision, previous revision. All right. So first of all, he'll change the matrix state from release to in work. So he can start working on that assembly. All right. Here also you can change the maturity state very easily into the 3D experience adding tab. So he has changed the status from release to in work. Now he'll open the sub assembly. Okay. Because the changes that that we should make is in the sub assembly. All right. So that is the plate that was causing the issue. It is a sheet metal plate. So what he'll do, he'll just remove that plate. Right. He'll delete all this plate. He has locked the assembly and he will insert the new part that has been already created. He just have to, insert it and have to constrain that part. All right. So he'll search for that part. Yeah, we'll got that part. He'll just open it. All right. And place it. Okay. It's easy to make a part with the help of assembly mates. So what you'll have to do, you have to just select the geometries. Okay. And SolidWorks will automatically suggest what kind of constraint it requires. or what kind of constraints are possible. Constraints are basically in designing term in SolidWorks language we are saying mates. Okay, mates are used to constrain our assemblies, and in SolidWorks we can easily like click to references. Okay, I'm just clicking to references and it pops up. What are the constraints? What are the mates that are possible between these two selections? So I'm just selecting those constraints to apply onto my assembly. All right. Okay. So pretty easy, interactively you can do it. You can just drag and drop and see what are the portions that are not constrained. All right. And just select them and constrain it pretty easily. All right. Then I'll mirror this part to the other side also. Okay. I already selected plane. Now let me select part. I'll go to my dynamic mirror option. All right. And then I'll mirror it. Also, I'll constrain this part, some of the area it should get constrained. All right. So I'll constrain my whole part. Okay. So then before the saving the changes, he'll choose the change action under which issue has been raised. All right. So he'll select the first change action. Okay. So change action is been under construct and he'll save these particular changes that he has made into that particular change action. All right. So he's been saving this part. And you can easily see that the C1 revision has been created. Okay. And he'll just, now disable that change action. All right. So he'll disable this change action. Okay. Yeah, he has disabled it. And what he'll do now, he'll go to the change execution. He's previewing the assembly. He'll now go to his change execution. Okay. Now he'll send it to the approval. So he's changing the maturity state of his change action to the approval, but it shows him an error. The error indicates that some of the part is not in the frozen state. So he have to freeze them first to save them. Right. So he has frozen in all, and now he'll change the state to the approval. And now you can see it got approval. Okay. So it is an error prone process. It will not let you move ahead unless you follow its predefined workflow. All right. So he has forced to freeze all the files. All right. And then save it and then ask for the approval. Okay. So this is a full predefined workflow. Okay. If someone's tried to breach it or, forget to do the necessary, then, software will remind him to do that first. Okay. So my change action has been created and now I got notified that my change action is in approval state. So I will review it. Okay. I'll go to change action. Okay. Realize changes. I can see the newly created revision of my model packaging machine. All right. Okay. So what I'll do now, I'll compare my newly created revision to that old revision, that B1 revision. So what I'll do, I'll go to innovate compare and I'll compare my C1 and B1 revision to see what are the changes that has been made into this particular two revisions. Okay. So I can see the bifurcation from the structural manner. Okay, I can also see what are the changes that has been made into the properties. Okay. And we also have an option of 3D view where we can spot the 3D visible difference between two revision of the survey. All right. Here you can correctly see that the two color combinations are given. The orange color state the new changed part into new revision, and the blue state is a old revision parts that are that has been into revision B1. All right. So we can spot the difference pretty easily with the help of 3D view option. Okay. Even a layman can see what are the changes has been made. Okay. Same with the product structural explorer. You can just scroll through it and see what are the changes made there. Okay. So I think I'm satisfied for whatever I am seeing here. Okay. So I'll go to the approval tab and I'll add a comment to it and approve this whole process, whole change action. All right. So let me add the comment, like great work, good work, whatever you want to add. and I'll just approve this change action. So I have clicked on the approve. Okay, so my change action has been approved. So I'll click on that notification to execute the changes. Yeah, so my change action has been completed. Correct. So I also change the state of my issue to the completed, because my change action is completed, so my issue is also completed. Okay. All right. So it is also been completed. So now what I'll do, I'm following a practice, from the start, as you have noticed in the video, that whatever the changes I am having, I am also updating into my community. So what I'll do, again, same, I'll go into my 3D play, load my new revision, add the markup tools. Okay, so whatever the changes that we have made. All right, I'll also add the text to it. So what I'm currently doing here is I'm adding a history, my product lifecycle is currently following a history into my community. Whatever the changes I've been made, I'm just updating it to my community. So whenever a new guy comes in, he can just scroll through that community and see the whole history of this product development. What are the stages, or at what time this changes has been made. What is the gap of initiating some previous issue and some current issue. So he can track all of this thing with the help of community. So that's why I'm keeping it into the practice that whatever the changes I'm making into my assembly, I'll make sure to upload it into the community. Okay. Okay, so we have seen the issue management. We have already done the project planning. Okay, so next, what? So let us focus on how easily you can create a concept using a tools like 3D Sketch, right? So this is my production guy, Jamie. Okay. What he'll do, he's excellent. He's having excellent field knowledge. All right, but he hasn't that much proficient with the tools like CAD tools and all. Okay, but if you want to express his concept, so how we can do it, we'll see that. So he is going into the 3D sketch. All right, first he will select the community in which he want to publish this concept. All right, so he's searching for the community. Yeah, he's got that labeling machine community that we have created. Okay, so with the help of symmetricity and with the help of tools, he's creating a concept. So this concept is basically from the frame structure for our labeling machine. All right. So you want to create, he want to express his way, like how we can control the vibration of this machine by just upgrading the frame. All right. So he's giving us a little bit of thoughts. Okay. So you can see how easily he's just switching in between the tools. Okay, we doesn't have many tools. We have just 3 or 4 tools, and with the help of these 3 or 4 tools, you can easily created a concept, all right, of the structural system, and he is now publishing into 3D Studio. He has commented it, frame changes, all right. So what he'll do now, he'll go to his community tab, okay, and you can see his concept has been updated into community. So he has given his input, and without the knowledge of proficiency, being the proficient into the CAD tool, do it pretty easily, right? So now, my engineer, Jamin has suggested some changes into the frame. So let my CAD designer handle those concept, and their task is to bring that concept into the reality. And so we are going to use a structural system option to do that, right? So what are some of the benefits of the structural systems? Okay, so there are many benefits to the structural system, as a saving time and development cost will also got saved, and it will increase your productivity. So let us see how it can increase your productivity, right? So what I'll do, I'll go to the SOLIDWORKS environment to create the support structure for the leveling machine. I'll go to the 3D sketch to create the skeleton of the structural concept. All right. I'll constrain my sketch. Okay, and again, I'm trying to reflect exact same skeleton that has been suggested by my engineer. All right. So again, I'm constraining legs for my structural system, and boom, within a few seconds, my skeleton has been created. Then what I'll do, I'll assign a square members with the help of structural system. All right, I'll choose the standard accordingly, and okay. All right, I'll also add some corner management, and my structure is been ready within a few seconds. All right, then what I'll do, I'll go to static simulation tools. Well, I'll validate my design. All right, so first I'll create a new study, then I'll go to fixtures to apply fixtures to it base. Right. Okay, so I have applied a fixture to 4 bases, and then I'll treat all member as a beam element to get more fast and accurate result. All right, and then I'll go to the respective load to apply it. All right, I'll select the direction of the load, I'll select the tendency of the load, and then okay. Okay, and I'll just create a mesh. So my 1D mesh element has been created. Then I'll assign appropriate material to my whole frame structure. So I want to assign a stainless steel material. All right, and I'll apply it. And now what I'll do, I'll just run the study. Okay, so my study has been completed within a few seconds. And after study completion, we can check the maximum stress and displacement plot into the result tab. All right. We can also animate what are the displacement that has been taking place. Okay, it is a virtual representation. Right. And we can also create a plot for factor of safety for our model. All right. So that way we'll know our model is safe or not. So I'm just generating factor of safety, and I think my model is way ahead from like whatever I need. So it is safe. Okay. So now what I'll do, I'll first of all save this into my space. Then I'll create a manufacturing drawing of this frame. Right, I'll choose the shape that I want to use. Then I'll project the views that are required. I will also generate a bill of material, and I'll project each and every member. Okay, and I'll also with the help of automatic dimension, I'll also drag our required dimension into it automatically, and then I'll save this whole manufacturing drawing into my space. Okay, so the revision has been added. So let me grab all those files from the cloud, and in the cloud now I'll change the maturity state of this file. All right, so there are many options are given from the 3D experience add-in. You can do it from the collaborative lifecycle app. You can do it. All right, so there are many options to do these things. Okay, so yeah, we have created the structural system drawing pretty easily. What are the benefits of it? You can automatically create a view, place the dimension, automatic production quality details are given there. Drawing errors will be avoided, and the cut list table, which is basically bill of material for all kind of members that has been used in it, and it contains the details like what is the member channel is called, what is the length of it, what is the weight of it. Okay, and it automatically generate that bill of material for you. Okay, then we also witnessed the validation, how we can easily validate, quickly apply fixture and all, reduce the need for costly prototype, eliminate the rework, save the time and development cost. Now let us move to the assembly motion. So I'm not going to show you all the setting regarding the motion and all, but let us preview what is the capability of our SolidWorks motion. So we have initiated our project, we have created whole project. All right, so let us see how this whole streamlined process will work like, okay, with the help of SolidWorks motion. Okay, so we can easily replicate the real life motions of our assemblies. and also calculate the force acting on every object. All right. So my bottle, currently I'm demonstrating a process flow of how pharmaceutical bottle is filled, capped up and labeled with the help of SOLIDWORKS Motion. All right. So my bottle is then capped, then this cap will get fit with the help of tools. And then it will go into the next process, which is, like labeling the machine. So, precise contact option, material specification, let you manifold accurate and next to actual scenario, how that object is going to behave in the real life situation. All right. So my next thing is to get my bottle labeled. Correct. So this is a pretty easy process. Not as much as stations in filling and capping process, but still. All right. So it is going into the labeling process, and in between it got labeled. All right. So with the SolidWorks Motion, you can replicate this whole process. You can present it to your vendors for the demonstration purpose, and you can also use that data to validate your whole assembly. Okay. So I think that was our last topic. Let us move to the summary. Okay. So in the summary, we have seen we have already witnessed what is a platform. Right. So the 3D Experience platform is an ecosystem to connect people, process, and data and apps to ensure that your work is not affected at any point of time. Okay. So we'll ensure like you can do your work from anywhere, any place, in any device. So most of the data management tools we have witnessed, it is a web-based. All right, whether it is your project planning, meeting, or whether issue management tools we have seen, they all are the web-based. You can access it from any device. It is login-based license. All right. So it is very useful tools. We have seen meeting and planning tools, project planning tools, product revision tools. Okay. So ultimately, its purpose is to help you guide through your whole life cycle, product life cycle, right? And never let you feel any kind of disturbances throughout your whole product life cycle. Then we have seen issue management, change action, how we can do it. Then we have seen concept creation with the help of tools, how we can execute and validate those assemblies. And lastly, we have witnessed the assembly machine. So I think that's it from my side. For the more queries and for further queries and more excitements, visit our site and reach out to us. Okay. So we have offices at 3 places as introduced earlier. Vadodara is our headquarters. We also have office at Ahmedabad and Surat. All right. So in case of any queries regarding the demos, you can contact our marketing team, or you can go to our website and just click on the queries. All right. So thank you so much for attending this session, and that will be all by myself. Right. Have a nice day.